In this video, I'll be solving the second part of third problem of UPSC Civil Services 2022 Statistics Paper 1. So theoretical probabilities in the four cells of multinomial distribution are 2 plus theta by 4, 1 minus theta by 4, 1 minus theta by 4 and theta by 4, and their respective observed frequencies are 108, 27, 30 and 8. So we need to estimate theta by maximum likelihood method, and we also need to obtain the standard error of this particular estimate. So we are having multinomial with cell probabilities as a function of theta. So P1 would be 2 plus theta by 4, P2 would be 1 minus theta by 4, and P3 is 1 minus theta by 4, and P4 is theta by 4, and their respective cell frequencies are also given, observed frequencies. So they are nothing but 108, 27, 30 and 8. So now likelihood would be 2 plus theta by 4 whole to the power n1 into 1 minus theta by 4 whole to the power n2, 1 minus theta by 4 whole to the power n3, theta by 4 whole to the power n4. So that means the log likelihood would be, so the log likelihood is nothing but n1 ln 2 plus theta by 4 plus n2 ln 1 minus theta by 4 plus n3 ln 1 minus theta by 4 plus n4 ln theta by 4. So that if we simplify n1 ln 2 plus theta, n2 ln 1 minus theta plus n3 ln 1 minus theta plus n4 ln theta minus n1 plus n2 plus n3 plus n4 ln theta. So that's like an additive constant. So if we rearrange terms a bit, so n2 ln 1 minus theta plus n3 ln, so n1 plus n2, n2 plus n3 ln 1 minus theta plus n4 ln theta minus capital N ln theta. So that is our log likelihood L of theta. So we can find this capital N from this. So capital N is 108 plus 27 plus 30 plus 8, which is 135 plus 38, which is 173. So if I differentiate this with respect to theta, this is n1 by 2 plus theta minus n2 plus n3 by 1 minus theta plus n4 by theta. So if I equate this to 0, that means 108 by 2 plus theta minus 30 plus 27, which is 57 by 1 minus theta, plus 8 by theta is 0. So that means 108 by 2 plus theta plus 8 by theta is 57 by 1 minus theta. So that means 108 theta plus 2 theta, 16 plus 8 theta by theta square plus 2 theta is equals to 57 by 1 minus theta. So that means 124 theta plus 16 into 1 minus theta is 57 into theta square plus 2 theta. So that means 124 theta plus 16 minus 124 theta square minus 16 theta is 57 theta square plus 114 theta. So that means 181 theta square plus 6 theta minus 16 is 0. And more importantly, if we consider the range, since these are probabilities, first thing P4 is theta by 4, so theta must be greater than 0. Now 1 minus theta by 4, numerator must be greater than 0, so theta must be less than 1. So theta should be in between 0 to 1. So if we find the root in between 0 to 1 for this quadratic equation, we are getting it as approximately 0.2663319. So this will be the maximum likelihood estimate of theta. Now we also have to find the standard error. So for standard error, we can find the observed Fisher information. So Fisher information is nothing but minus dou square by dou theta square of this log likelihood. So that is minus L double dash of theta, which is n1 2 plus theta whole square plus n2 plus n3 by 1 minus theta whole square plus n4 by theta square. So that is nothing but n1. So n1, so if we substitute the values, we got theta hat MLE. We also know this n1, n2, n3, n4 values. So I have already substituted. So for the estimated theta value, the Fisher information, I am getting it as 231.705. So now, so asymptotic variance of this theta hat is nothing but this inverse of this information. So standard error is nothing but square root of 1 by I of theta hat, which is square root of 1 by 239.705, which is approximately 0.06459. So by using this, we can also find a 95% walled interval. So that would be 0.2663 plus or minus 1.96 into 0.646. So which comes out around 0.139 comma 0.394. So yeah, so that's the standard error and maximum likelihood estimate of this theta involving this multinomial distribution with this theoretical probabilities in terms of theta. So that's it for this video. We'll meet in the next video.